YouTube, welcome to this next installment of the Evione blog. Today I'm going to continue talking about the Evione power supply, the digitally controlled power supply which we're busy designing. I'm also going to share some of the code with you guys. I've based it on Arduino for simplicity for those of you that are keen to build along with this project, as the Arduino is quite easily available pretty much anywhere in the world. And especially here in South Africa where a lot of components aren't easily obtainable, the Arduino is pretty much everywhere. So I'm basing the control of the digital power supply on that. We're currently working on revision 7 of the power supply. We haven't built per se yet. I have breadboarded the design and it does work pretty well, but we haven't built the actual power supply yet, as I'm still ironing out some kinks in the initial design of the power supply. I'm hoping to have a pretty much very usable, very powerful, if you'd like to call it that, power supply. Not powerful as in power, as in wattage, but powerful as in functionality. If you're going to build a digital controlled power supply, why go half cocked with it? You may as well go all hog, build the whole thing. Keypad entry, pretty much on-off power controls, everything. So we're going to slowly build that up in stages so you guys can see how those stages work. And yeah, that's pretty much it. Let's get right into it.
Hey, good morning YouTube. Dion here from Evione Electronics again. Just been going through a few of the designs that I've been working with within the Proteus design package, and based on our Evione power supply that we've been working on, this being the groundworks of said power supply over here. Last episode covered how the Arduino talks to the digital to analog converters, the switching talks to the Arduino, and then the DAC's output to a set of op amps, which then input into the adjust pin on the LM317 regulators. Now, for today's episode, I'm going to work on a few design changes to this system, because I feel that by individually controlling the outputs on or off, we can add a bit more functionality to this power supply. Also, by changing a couple of key components, such as the LM317, possibly for something like the LM338K, we could already get a bit of an improvement in current handling capability. And I'm also going to go through a bit of the code on this power supply, the Arduino code, so you guys can see exactly what's going on. Also, under the subject or the information about this video, you will find the links to be able to download the sketches, the Arduino sketch for this power supply. So you can pretty much build your own and head on from there. But before we do so, I need to make a few changes to the output stages over here, such as adding an extra tip 41 to this relay, breaking the connection over here so that the two outputs are controlled individually. Also, what I'd like to do is have a measure point here, which is now, well, one here and one here, but let's just concentrate on channel 1, for example. Measure point here, which will measure the preset voltage, which means that technically you could preset the voltage while the relay is off and you're not outputting anything. So you can measure the preset voltage displayed at the top, and then your measured voltage would be measured across these points over here as they are now with the voltage dividers. You need the similar voltage dividers here, same sort of setup, same sort of coding in the Arduino. But so you could have on your display, you would have your preset, channel A preset, channel B preset, channel A actual, channel B actual. Just a little bit of fanciness, not really needed, but nice to have, I think. So I'm going to go ahead now and make a few changes to this diagram by adding an extra tip 41 switching transistor. You can use another kind of transistor if you like. I mean, any transistor will work. I've just used tip 41s because that's what I have in my spares bin over here by the dozen. So let me go ahead and do that, and I'll be back in a short while. Okay, so I've implemented some changes over here now. The primary circuitry I've left the same, the regulators I've left the same, the output I've left the same. What I've done is I've added another stage before the relay with ADC and ADC4, ADC3 and ADC4 links connecting to ADC3, ADC4 on the two spare A2 and A3 on the Arduino Uno. So basically I can read a preset voltage while the channel is switched off using this RL on RL on, RL1 on, RL2 on signals, which also come out from the Arduino. At the moment, I have the Arduino just throwing these on after the initial delay, so it waits a few seconds for everything to settle over here, and then it switches these two on, so they're just on. But for later implementation, I am thinking of having soft touch buttons to power these channels on and off, and also if there's a fault condition to power the channel off, etc. But that'll come at a later stage. For now, what we've done is we've put these two signals to monitor preset voltage or output voltage. At the moment, I've got no sort of current metering on this power supply. This is all voltage. The current metering section will come a bit later, but being a little 1 amp power supply for now, maybe I'm not too concerned about that. So I've recoded a little bit to initialize these additional relay pins, etc., to fire on these relays. So let's power up, and we should get our 1.25 or 1.26 volts output on each rail as soon as everything stabilizes. And there you go, there you have it. Okay, so we're back to more or less the traditional design, just with these two additional reading points over here, which I have not implemented in the code as yet. But let's have a look at the code, the Arduino code, and see exactly where it stands. I'm using older Arduino software again because my new software seems to be giving an issue with Java. Just wait a few seconds for that to load. The machine does run a bit slower when I am doing a screenshot recording, and as you can see, I've got huge amounts of data copying across over here, which are not helping with speed, etc. Alright, if we go to revision 7, which is the current software revision I'm busy working on at the moment. As you can see, we are using the Adafruit MCP4725 libraries, standard liquid crystal libraries, etc. I've now added the two additional analog channels over here. They're not really doing anything, like I say, yet. All the math work, etc. Little boot up name, web address, the usual. This is my loops, my counts for my signal up and down. 490 to 495 of my digital to analog converters. All the control software. And at the moment, all I'm doing is I'm reading the VN1 and VN2, which have been defined as, if you look back, you've got analog 1 and analog 2 is A0 and A1 on the Arduino, which are later on defined as VN1 and VN2. So what will happen is those signals are then displayed on those registers, or that the information stored in that register is then displayed on the screen after it's read in from those two analog ports. Quite a simple little setup, and then this is a loop, so it'll continue reading. I am going to now implement some code to read the input separately from the output of the relay stage. So in other words, it'll give me here while this is turned off. At the moment, if it's off, the reading that is going to be 0. So I wanted to be able to preset it so you get to where you want it, and then you push it, and then it activates. This will all be done on the Arduino itself. We are running out of pins on the Arduino, but we still have the 0 and 1, which can be made use of. So it's not a big deal, but it's still fitting on the Arduino Uno. If I wanted to go any bigger, I'd probably have to go with a bigger microcontroller. So, as you can see, we're operational. Let's pump up the voltage a little bit here on channel 2, and there you can see it is climbing. Very small steps I've got going at the moment. You can do it in predefined steps, but I'm just doing this for the experimentation purposes at the moment. On the final product, I'll probably have it climbing in predefined steps. Pretty decent, I'd say. Again, the maximum, if we go backwards, boom, there, 28.51 volts. So nothing has changed in that aspect. Now let's have another look at how we can implement more changes to this power supply. What I'm going to do is I am going to finish off this episode by saying that's as far as we're going to go for today. I'm going to do a few more implemented changes, and then I will go through those changes with you in the next episode of the Evione power supply build along. But as you can see, slowly steps are coming into play. But before we go, I'm going to share with you guys the link, which should be up on the screen at the moment, and will also be in the comments, for the source code as well as the schematic diagram for this power supply as it stands here. So for those of you that want to build it as it stands, which is operational and working, you can go ahead. And for those of you that want to experiment with the reading, writing of the inputs, output stages, no problems, you can do that. So thanks very much for watching, guys, and until next time, take care.